All right. Thanks. I was waiting to hear if that sound pops up that says recording started. But yeah, thank you very much for coming to this talk. Thanks for the invitation. It's a great honor to be here. I want to say, while I have everyone here, that I apologize for not being able to have the search seminar at NYU this year. Hopefully, soon enough, we can do it there. If next summer looks promising, maybe we can do it then, but hopefully soon enough. But thank you very much for the organizers for having this kind of instead, which is really great. Okay, I'll present this. This paper is quite preliminary, so we really will benefit from your feedback. This is joint work with Poppy, who's a PhD student at NYU, and Ella from UCLA. And yeah, the title is Search Gaps. Hopefully it will make a little bit more sense in a few minutes. Okay. Motivation, I think I don't need much here, right? We all know consumers are exposed to lots of information before making a purchase. And so they got to figure out which products to consider, which ones to ignore. And we have a very rich literature. And this is just scratching the surface in terms of what is out there. But a rich literature trying to model what products consumers consider and which ones they ignore. And the types of decisions that we typically think about modeling are the following. And I'm going to be talking about, I'm going to be talking from kind of the perspective of a sequential search model, but many of the things that I'll talk about don't apply just in the sequential search model, but just for illustration here. So the decisions that are modeled, right? I think about modeling the order in which consumers search, and these are the Weizmann Pandora boxes if you're curious. Which products consumers search is another decision we typically think about, and then obviously what people end up buying conditional on searching. And the way we think about modeling this decision is as follows, right? We think about consumers trading off a benefit from searching against a cost, and so they're going to continue searching as long as the benefit from searching is greater than that of stopping, right? So the consumer has searched some options, and then if they judge the benefit from searching to be greater than the cost, then they would open some other box, right? Search another product, otherwise they would stop, okay? So nothing kind of new. What I'm trying to emphasize here is that these types of models are gonna predict a consecutive search pattern, right? So if you're going to search 3 products, you're going to search them one after another with one stopping decision at most at the end. Okay. But what we see in the data is something like this. We see instead what I'll call search gaps. And this is a figure from our data, which you're not supposed to completely understand because I haven't introduced it. But what I'm showing here are the number of searches in one category that a consumer performs over time. So what you see is a consumer searches, I don't know, 5 products today, stop, and then they restart their search tomorrow. They search another 5 products, and then they stop and they come back tomorrow. So what that means in terms of our, in terms of my example from before, right? Even if the consumer searches 3 boxes here, 3 products, when they decide to, and whether they decide to take a break in between these searches is going to generate different patterns in the data, right? It's going to generate these types of breaks or search gaps.
Raluca, can I ask and just make an unfair comment? So all of this assumes that search is a discrete event, but there is literature that says, you know, there's also the question of how much to search each thing, or even to kind of go back and uncover different aspects of things that I'd already looked at, like Bettman Payne Johnson or whatever it is.
Yeah, so and I have a paper too about search duration. So so definitely I'm thinking here about, I'm kind of abstracting away from that, but there's no reason why not, why you wouldn't, you couldn't think about that as well, right? Going back to search to obtain more information about one of the products. But what I'm trying to focus on is these breaks, right? You could go back to obtain more information even without a break. And so we typically don't think about these breaks as choices in the literature, and we're gonna try to argue through this paper that those gaps, these breaks are also choices that we should maybe think about.
Okay, but what interpretation of a break is, let's say I'm looking at computers, I'm looking computer by computer, and then in a Bettman Payne Johnson sort of way, I realize that CPU is something I should care about, but I don't know what CPU is. So I go away and research CPU. That won't show up as activity
so definitely. So this is a great way to look at the following slide. So the literature, so what you're saying is there are many cases when it's fine to kind of ignore these breaks, and definitely, right, the literature has ignored them, either because we don't observe, and Ella and I have been guilty of this too, right? Either because we don't observe a break, because you only observe kind of a sitting or like a one search session of the consumer and you can't kind of connect them, or you kind of think like Eski was saying, that there's no reason to kind of break them up because they kind of all belong to the same search, so you lump them all together, or you might think that they're independent. So there are many reasons when these gaps, right, they occur for reasons that are unrelated to the search process, right? They occur for reasons that are kind of random. For example, you need to go off on a tangent to kind of investigate more on a certain aspect because you don't know much, or because you have a meeting, or for whatever other reason, right, that breaks up your search. What we're trying to point out is that there are reasons for taking a break that are related to the search process. So let me just give you some examples of those, right? You might stop searching now and want to restart later because you think that later prices might be lower, or other product features might be better, for example, right? And we do that a lot, for example, in our previous life when we were searching for airline tickets, because airline tickets, right, vary so much, prices vary so much, so it makes sense to kind of stop and restart in that case. Maybe when you're unsure of what else to search, because, for example, it's a new feature to you, or it's a new product category, you can't afford to buy it. This is not supposed to be an exhaustive list, right? So these are just some examples. Here's another one, and this is the one that we're gonna be focusing on. Fatigue could also lead you to stop and restart searching, right? Because even if the cost of searching is relatively low, if you keep searching, at some point you might get tired of searching, right? Because maybe your search costs are increasing while you're searching, but they get reset during a break, which allows you to restart your search. Okay. We think that fatigue is important on its own, and it's very related to search, but it's kind of ignored by a lot of the literature. I know you're thinking about Stiglitz maybe, or papers like that, where search costs are increasing in a number of options. What we're thinking about is not just that aspect, but also kind of the resetting part, right? The fact that you're depleted, which through a break, you reset those your effort level. So let me give you a few examples from kind of the media that kind of describes this, right? So
Raluca, can I ask maybe a question? Some of these examples that you had, they suggest to me more that you do not start searching. So for example, if you cannot afford to buy, it's maybe not that you want to stop at some point, but probably you will not start in the first place. And maybe also with airline tickets, if you know that later they might be cheaper, you probably will not. Is it important that the distinction between a gap in the search activity, which is really, say, fatigue, you only have a gap because you started and then you get tired and then you continue, or this delay that you actually do not start in the first place, is that something that is important, or that you don't really?
No, I think both are important, and what's most important here is the fact that there's a time dimension to search, the fact that you choose when to search. And so you might choose to delay kind of the start of your search, or you might choose to delay once you've started. What we're trying to emphasize is exactly this time dimension, this decision of when to search, not just what to search and in what order. That's exactly kind of what we're trying to emphasize here.
Can I, yeah, just sort of on fatigue. I mean, is it a reasonable way to think of the search cost increasing is it jumps to infinity at some point? So, you know, I'm in my lunch hour at work. The seminar starts at 2. When I was there, the seminar starts at 2. I have a spare half hour, so I flick through some things. And, you know, I'm not really planning to buy it for another month, but, you know, this is better than working on the 27th referee report. Is that what we mean by fatigue? Or?
I mean, I would think about that as more of a kind of a budget of time. I only have the 5 minutes before the seminar starts. So it's a little bit different from, we're thinking about kind of a monotonically increasing, you know, cost here. And we have some evidence against this budget of time story. So okay. we think about these as kind of different mechanisms. Okay, so fatigue, so kind of from the news, right? This article I think says it best, right? There's consumer fatigue. Every time I have to shop, I need to take a break and take a sip of wine because the search process is tiring in itself. So that's kind of what we have in mind. There's lots of evidence that the amount of information makes consumers tired, and that obviously has lots of managerial implications where companies are trying to reduce this fatigue level. Okay, so what we're going to do in this paper is first show some empirical evidence that relate fatigue to search gaps. Okay, let me just emphasize that fatigue is something that's unobserved, and so it's quite difficult to come up with evidence for this. So we're going to use this new hopefully exciting data set on consumers' entire browsing history. And we're going to show that consumers who are older, consumers who search on websites that are slower to load, right? Their speed is very low, or that have a lot of information, or have a lot of information that's very hard to read. All of those things, which we can think of as proxies for fatigue, relate to search gaps. And then second, we're going to develop a model of search gaps with fatigue that's starting from the Weizmann model where we add this additional choice of when to search a particular product. And that's going to allow us, and when we take this model to the data, to quantify not only search gaps and preferences, but also say something about fatigue levels. Okay, why do we think this is important? Obviously, if we think fatigue is important, measuring it is important in order to reduce it. So that's kind of the first reason here. And then on a more subtle note, hopefully this can help companies target consumers better. Like if you know the consumers stop, not because they don't like your product, but because their fatigue was low. So that might allow companies to target consumers better. And then I know many of you are interested in this literature on prominence and search, and the order in which consumers search, right, tells you something about the elasticity of your residual demand. We think we can maybe add something, a nuance there, where we say search being searched second after a break versus before a break. That also says something about the strength of that match value with the prominent firm. Okay.
Raluca, can I ask you a question? So yeah. I missed the first 2 minutes, so I apologize if this is something you already talked about. But so, you know, following what you were saying, to me, the first sort of thing that these breaks somehow highlighted was the fact that when I do a break after searching for something, a lot of the information I obtained in the first search somehow goes down the drain. This is not something that you mentioned, but seemingly has to be important.
For getting,
I don't know whether you're going to assume free recall in your model, but
yeah. So So that's something we can test. So forgetting is definitely a reason why you might go back, because maybe you forgot what you searched. That's again true regardless of whether you take a break, but maybe it's more true after you take a break indeed. We can look at revisits. And we haven't done it here. I have another paper on search revisits where we look exactly at that, like whether you're more likely to revisit a product that you just searched versus one that you searched in the beginning of the search process. And we find that people are more likely to revisit something that they just searched. But yeah, that's a good point. We can kind of do a similar test here to say something about forgetting. Yeah, thank you. But yeah, for the model, you'll see we will assume full recall. Okay, I'm going to start with the data and then provide some empirical patterns, and hopefully have enough time also for the model and some estimation results. So here are the data. We have data from GfK on consumers in the Netherlands, and we see everything that they do online, conditional on shopping, at least in searching at least once in the apparel category. We have about 2.5 months of data. And again, we see everything that consumers do online. And let me just emphasize the richness of the data here just for a second, because it's going to be important for looking at fatigue as well. Right, so we see, let's say, a consumer going to Facebook, then checking news, and then going to, you know, an apparel a website that's in this category. And we observe the entire URL of that visit, of that click. Right, so we see that they go to the homepage and they go to a particular list of products, a particular product. We see transactions, all, you know, with the timestamps as well. And we see what they do after also. So that's going to allow us to say something about that budget of time. Do they stop? Because, you know, and that's the last thing that they do is something in the apparel category. Do they go and do something else? So we observe everything that they do online. And then because we have these full URLs, we can then scrape information on the exact products that they're looking at, and the product category, prices, and so on. So that's what we end up doing here. Okay.
So does that mean then that you only know that a purchase was made at a website? So if they looked at 10 things, you don't know if they put 2 of those in their basket or all of those in their basket?
Yeah, so we do see adding to cart, right? So as long as this information is coded up in the text of the URL, we can see it. So we can see multiple add to cart visits to the, and then a transaction.
And how do you interpret multiple purchases from multiple sites on the same day?
So that definitely happens, especially for clothing, but it's not that common. I should have the number here. So right now we're looking at just one, you know, sessions where consumers buy one at most one thing.
Sorry, and then this means that you basically observe the price when you scrape it, which may not be the price which was in place, you know, in 2015, no?
Exactly. And that's going to pose some problems, and you see we end up not being able to use the price when we estimate the model, exactly for that reason, because we won't see, you know, the actual price that the consumer saw on this particular day. We see the price when we scraped, so we don't observe any variation in the price. So once we control for, you know, website fixed effects, right? For H&M, Nike, Adidas, or for those fixed effects, there's no variation in the price. Yeah, so we're going to end up not using that, unfortunately, but okay. So let me just kind of illustrate what how I'm going to define some of these things and what we mean by gaps here. Right, so this is an example of a consumer and all their searches over a particular period of time. I highlighted here, right, the clicks in our category, but we observe all of the other clicks as well. Clicks that are separated by less than 30 minutes are grouped into sessions. This is kind of the standard in the industry. And then what we're going to be looking at, okay, sorry, and then we also observe a purchase if it happens. And so what we're going to mean by search gap is a break in between two sessions. Okay, so you search these products here, then you take a break, let's say you stop and you come back tomorrow. That's going to be the gap that we're going to be looking at. And then a spell is all the sessions leading up to either a purchase or, stopping search completely. Okay, let me skip that and show you some patterns relating to search gaps. So how frequently do we observe search gaps in the data?
Raluca, just to go back to that one for a second and to think about the budget of time and breaks. Like sometimes the apparel search is at the beginning of an internet session, sometimes it's at the end of an internet session. Yeah. So, I mean, you could imagine I'm internet fatigued or specifically apparel search fatigued. And I wonder if there's anything interesting there empirically.
Yeah, so if you are, I'm not sure what you're asking. I'm gonna kind of so what we think is maybe interesting there is that we can't really disentangle, like, are you internet fatigued or apparel fatigued? We're gonna say that if you search a lot in this category, you're probably tired of the category.
Yeah, but you have the data to potentially distinguish those, because sometimes the apparel search happens at the beginning of a session and sometimes it happens at the end of a session.
So what I've looked at, and I don't have the data here, is, do you search a lot before you start searching in apparel, and how that correlates with how many things you search afterwards. And then we can look at, do you search more social network? You go a lot to Facebook before, probably you're less tired if you do that than if you go to news websites or something. So we can maybe add that if you think that we don't have that right now, but that
depends if anything interesting comes out of it.
Yeah. So indeed, we see that if you search a lot more, if you spend a lot more time or you make more clicks, you search fewer fashion websites afterwards. So I don't have that here though. Yeah. Okay, what I'm showing you here is just simply the number of gaps that we observe in the data. What you have in the histogram on the left is just this histogram, right? The number of gaps. About 27% of spells don't have any gaps. Everything else, so 73% of, so most of the spells have at least one search gap. So this is kind of a prevalent phenomenon. If a spell has a search gap, on average, it has about 8. A spell lasts more than 2 weeks, and this break lasts at least, at least a day, on median 1.5 days. Okay. So it's relatively short. You don't wait, so probably features are not going to change in that period of time. You might be thinking some of those gaps are because people are switching categories, right? Maybe I'm searching for shirts and then tomorrow I'm going to search for shoes. And what I'm showing you here is conditional on each of those subcategories. You still see a lot of search gaps. So about on average, more than 40% of spells have at least one gap. So this is kind of we think a prevalent phenomenon across categories.
What was the common return policy at this time? Like, what if these were people purchasing, it gets delivered, they return it, and each time they have a 2-day gap as they wait for shipping, or a 3-day gap?
So this is what I'm showing you here. I'm going to answer your first question also, but what I'm showing you here are gaps before a purchase happens. So this has nothing to do with returns. And then since we observe thousands of websites, right? Every website has a different return policy and shipping policy. So we have some data on that, but this is kind of unrelated to what I'm showing you here. Okay. One more thing before I show you some patterns relating search gaps to fatigue. And this we've already talked a little bit about. I wanted to show some patterns that search gaps seem to be choices that consumers make. we observed that most sessions don't end in a fashion click. So close to 90% of the sessions have something else after the click. What happens, what are the most popular activities after you're done searching for fashion, even on the weekend and at nights, right? Is checking your email or going to Facebook. And we think these are, right, the consumers could have searched more on in the fashion category, but they chose to do something else that looks a lot like leisure. We observe some gaps within the session as well, right? So sometimes you search for shoes, then you go to Facebook, then you come back to shoes. So we wanted to see what happens in those breaks. Most of the time consumers are kind of a similar pattern. They go to email and social network.
So Raluca, email and social networking are kind of interesting because rather than me getting bored, that might be me getting distracted, right? I might get a notification to say,
yes,
you've got an email.
Very nice. So we also observe these email notifications and we want to see what happens. So you started searching for shoes, let's say, you get an email notification. What do you do after that? And so most consumers return very quickly. So within 5 clicks or so to searching in that same category. So again, we think that these are choices that consumers make. Okay, so that's kind of a lead to kind of show that I still have to convince you that this is somehow related to fatigue, right? That these breaks are somehow related to fatigue. So let me show you some patterns there. We have 2 types of evidence. One is we try to look at some proxies for fatigue. Again, this is something unobserved, so it's quite hard. We're gonna have 3 types of proxies. We're gonna look at demographics. We're gonna look at time of the day when the search happens, and then some website features. And the second thing, second evidence we're going to present is looking at the number of options you've searched so far and how likely you are to, like, so related directly to how tired you might be and how likely you are to take a break. Okay, so let me show you this first piece of evidence. I'm looking here at the number of search gaps that happen in a spell and relating that to those 3 proxies for fatigue. So let me look at the first one. Looking at the age of the consumer and gender, we find that indeed older consumers are across the board more likely to have more gaps. For gender, we don't find kind of a consistent effect. There's some literature that says that men get more tired, but again, I can't find, we can't really find any evidence for that here. If we look at the time of the day, we kind of find that consumers searching mostly in the evening and mostly on the weekend, right, are less likely to have a gap, but that's right, it's less true in the last category. And then in terms of website characteristics, this is maybe the most interesting here. We gathered a lot of information about these websites. So one is we obtain the score with which the website loads. So typically bigger websites are going to have, they're going to be faster here. So consumers who mostly visit websites that are faster, have fewer gaps. Readability, this is an index of how readable the text is. And so higher means actually that it's less readable because it requires a higher level of schooling to understand that text. So actually the less readable it is, the more gaps you observe. More images, more gaps. The only one that, excuse me, we don't find kind of a 0 effect here is number of words. Okay, so all of these pieces of evidence kind of point towards fatigue affecting gaps. The second thing I want to show is related to the number of kind of websites that you've searched so far. So what I'm looking at here is the probability of a search gap and its relation to the number of websites that you've searched. So the more websites you've searched, our story is the more tired you are, and therefore the more likely you should be to take a break. And that's kind of what we see here. And even if we look at the total time spent, not just the website search, we see a similar pattern. Okay, so we think that these are some, this is some suggestive evidence that fatigue is related to search gaps. And that encourages to think about a model relating the two. Any more questions here before I jump into the model? Okay, great. So here's the model, right? It starts off kind of in the similar a way that the Weizmann model starts. So we have a number of options. They're going to be websites in our case. The consumer has searched some set S, some hasn't searched some other set. There's an outside option, and searching reveals a utility, right? And then the state variable is the best option observed so far. Here's how we're going to be different here. We're going to assume that the search cost has two components. One is this baseline search cost that we have in the Weizmann one, we have in most models. And then the second part is a search cost due to fatigue, right? The more options you've searched, the higher your search cost at that point. And we're going to think about that number of options searched so far as part of your state's space, right? So you have the options you haven't searched, number of options you've searched so far, right? And this after the previous gap, and then the best option you observed so far. Okay, so the problem is going to be the following. You're going to choose between stopping right now and choosing the best option so far, or continuing. But now this continuation decision is not just a decision of what option to search, but also when to search it. Right? You want to search the product right now, in which case you have to pay the higher fatigue cost. Right? You pay the baseline cost and you pay this extra fatigue cost, or do you want to postpone searching, in which case you don't have to pay the fatigue cost, but you have to pay this, you have to discount your future value. Okay, and the continuation value is kind of standard here. Now, this is easy to state as a problem. Good luck kind of solving it and trying to find an optimal solution here. Why is there no...
I'm sorry, I missed some things. You have discrete time here? There is no time?
Yeah, so time is just given by the number of options you've searched. There is no other time.
So if you take a break, it's some 1 unit of time, or 1 unit?
Sorry, I didn't explain that. So so I can either search the product right now, right, and pay this large search cost, and then continue, and next time period, right, T is increased by 1 because I've searched one more product. Or if I take a break, then that time resets. Okay, and I've started again from not having searched any options.
And you also discount the search cost. The search cost is also discounted.
Yes.
Sorry.
Yeah.
Okay, I see.
Does that make sense?
Yeah.
All right. Question?
And so that is independent of the length of the break, or?
Yeah, so indeed, so we're not modeling the length of the break, because we could also model not just the decision of when, but after how long exactly, right? Not just now versus later, but when exactly in the future. We're not, you can maybe think about this discount factor, we could model that as a function of total time break, like the break length, but we don't have that right now. Yeah. Kind of the idea is the consumer comes back when these costs have reset. That's kind of what the model assumes. Yeah, sorry, another question.
I'd like to have like 2 questions. What motivates me not to stop if I benefit from, having a break? Why I'm not, stopping all the time? Where is it in the model?
What do you mean stopping all the time?
So I have a break, then I lower my search costs, and I come back after a break. So that's a benefit.
It's
discount factor.
It's the discount factor, yeah. So if, for example, if you've observed a really high Y, right, the best option so far is really high, you'd rather, you know, transact right now or make a decision right now rather than waiting until the future where that value is discounted.
Okay. Another thought is like if the probability of not having the same product in the future, I mean, that can also be a motivation, you know, not to stop.
Yeah. So if stockouts are a real issue here, yeah, we're not capturing that part. If you're shopping around the holidays or something like that, where a lot of people are also shopping and stockouts are an issue, yeah, we're abstracting away from that.
Okay, thanks.
So the linearity of the fatigue cost is obviously relatively tractable, but should that bother me?
The linearity. I mean, it's going to depend on what we can identify, right? And so we're thinking about this both from the empirical and the theoretical perspective here. We could have a very interesting functional form there, but then that's going to be really what's going to identify that effect. What we're going to observe in the data is, do you search the third product with a break or without a break? And that's really all we have to identify that effect. So yeah, you could think about a more complicated cost, but that would be the drawback.
Related to this, so you're using kind of a linear scaling for within this period of search, and then a discounting for across periods.
Yeah.
Was there you didn't just use another kind of linear cost for waiting, where then, you know, every time you pass a certain amount, it's worth waiting and resetting, and then so on and so forth, right? You have like a multiplicative discounting across periods and a linear increase within. It just seemed almost like less tractable.
Yeah, interesting. I didn't. Maybe we can think about that. You can suggest that, and we can think about it offline. I'm not sure.
You could even then almost allow it to come down by small increments rather than large ones.
Yeah, but that part we don't really observe. But yeah, interesting alternative. We didn't think about that. Okay, let me just say a few more words. I don't know what I'm doing on time. Oh yeah.
Just a small question. Yeah. So is it reasonable to think that the prices stay stable during the duration of search?
Yeah, depends on the category. We thought about, you know, that's why we wanted to focus on apparel where prices are stable for many weeks, right? Kind of they only change with the season when the new trends come in. For other categories like airline tickets, that's definitely not going to be the case.
Okay, so because in principle I can just like the product and wait for the period of discounts.
Yeah, so there will
keep checking the prices.
Yeah, so that's a kind of a different mechanism that we're not capturing here.
So if Raluca, you might see direct evidence of that, because you could see people putting things in the cart, or you know, there's some change, but not transacting until another time or something like that.
Yeah. So okay. So that can show. So we can definitely observe.
I mean, like empirically, you might be able to kind of look for that behavior, or see if people are constantly going back to the same products, which would be a checking the price thing rather than a looking for new products.
I see.
So empirically, you have traction on that question, I think.
Thanks. We looked at revisits. They're as common as they are in other data sets. About less than 30% of clicks are revisits. Yeah. So, but we haven't done as much with adding to cart. Yeah, that's a great idea. Okay, let me just tell you very quickly why this is kind of an interesting problem. Easy to kind of state, and as you've mentioned, there are a few things, right? Even the simplest version of this problem is hard to solve. Right, there's no index solution, and just to give you some intuition for why that is, if we go back to the Weissman framework, it doesn't have gaps and it has constant search costs across time, right? So there we have an optimal policy. The moment you introduce increasing search costs, so even without the gaps, we don't have an index policy anymore, and that's because searching one option affects all the other options. So that assumption about you know, independence across products, it doesn't hold anymore. And then when we introduce gaps and increasing search costs, then we still don't have an index policy. The problem is very interesting. It becomes very similar to, maybe some of you know, these banded super processes, where the agent chooses not only a project or a product in our case, but also an action for each of those products. And in our case, when is the decision of when to search it. And those problems don't have index solutions either. Okay, so what we're trying to figure out is we want a solution that describes all the decisions that consumers make, right? Something about the order in which they search, when and which products they search, and the choice rule. So let me tell you about the order of search. It's not going to be the same one as in Weizmann, right? So the optimal search order when there is a state variable t here, so when there is fatigue, is not going to be the same one as when there isn't. You can imagine why, right? For the same reason, the index policy is not the same. You might want to switch the order once you started searching. However, under a monotonicity assumption, which we're going to make, we're going to be able to recover that optimal search order. So let me tell you about this monotonicity condition. So it says if the difference between two continuation values stays the same as time goes by, then I don't want to switch the order of two products, right? So if I wanted to search product J before K, when there was no fatigue, I still want to search J before K with fatigue. So under this assumption, so we're going to be making this assumption and then maintaining the optimal search rule from the optimal order of search from Weizmann. On top of that, and this is something that we might be able to relax. We haven't done that so far. We're going to make another assumption about the exact functional form of these continuation values. We're going to say they depend on the continuation value from the first period plus a function that depends on fatigue. So we could make this function a little bit more, so nonlinear. We haven't done that. Why do we do this? Because we want to capture the effect of fatigue, both on search costs and on this continuation value, but in a way that is simple to solve for. So that's gonna help us come up with search rules that are kind of similar to the Weizmann search rules that we're familiar with. Let me show you what those search rules are. So if we know the order in which consumers are going to search, we know that they're going to search in the same order as in Weizmann, then we can focus on the product that has the largest reservation utility and solve, figure out when the consumer is going to search that particular product optimally. Okay, so the problem simplifies for that particular product as we see here. Right? If the consumer stops, then they choose the best option so far. If not, they pay the higher search costs, or they have to wait to search the product. So obviously, the consumer is going to search now if the value from searching now is greater than both of those options of stopping and searching later. And the good thing is that we can find kind of solutions to these inequalities here, and that kind of look very similar to the solutions to the Weizmann problem. Maybe this is a little bit too fast here. I apologize for that, but that's kind of the idea. We're gonna be looking at these inequalities. They look very similar to the Weizmann reservation inequalities, and that's gonna allow us to solve for indifference points between searching now versus searching later versus stopping. And you can see there are solutions to each of those inequalities. And so the search rules we propose are the following, right? The selection rule, searching the same order as in Weizmann, but then the search rules are going to be functions of those extra reservation utilities, if you will, those extra threshold values that I defined on the previous slide. Okay, so those are going to give us new threshold rules for when you want to search now, search later, or stop. Okay. The good thing is that if you believe that, right, these search rules then impose restrictions on the preference and the search cost parameters that allow us to write down a likelihood function for observing search in a certain order, search gaps, and so on. I'm going to skip this, but these are exactly those inequalities that I showed on the previous slide, and we can put those into a likelihood function and estimate our model. I think I have only about 10 minutes, so I don't want to spend too much time here. Very quickly on identification, is that true, Dan, or what's my kind of time? I'm trying to keep track of that.
Let's say approximately. Well,
approximately, okay.
You've taken a lot of questions, so yeah, let's say 10 minutes.
Okay, so identifying the utility and the search cost parameters is similar to any other search models, right? Utility from search and purchase frequencies, search cost from the number of options searched. What's new here is identifying the fatigue parameter. It's going to be identified from when those gaps happen, right? So conditional on number of products searched, when exactly you search identifies that fatigue parameter. Okay, some estimation results. Before that, here's the utility function that we take to the data. Right? So we assume the consumer's utility is a function of website fixed effects. As I mentioned, we can't include prices here because we only observe prices after the end of the observation period. So we don't observe any time variation in prices. So controlling for website fixed effects, we're already controlling for prices. So utility is a function of part of the information that the consumers observes before the search. Here, just a function of website fixed effects and a shock, and then what the consumer is actually searching for, which they observe after the search, which is another shock, and then the search cost, which is very simple. We assume an exponential function here to ensure search costs are positive. Okay, so here are the results. We estimate the model and the top 3 categories in our data. You can see them there at the top. A few things to look at, right? The outside option is positive, meaning most consumers don't buy. So a lot of consumers prefer the outside option. If we look at the top 10 websites, unless you're from the Netherlands, many of these are not going to be very familiar to you. What you should know is Zalando is kind of the biggest website. It's kind of the Amazon of the fashion industry. H&M, CNA are also really big websites, and you see that they're the ones that are kind of more preferred by the consumer.
Sorry, are you estimating beta or you fixed that?
Yeah, so we fixed beta, and what we're going to do, and I don't have the results right now, is robustness to different values of beta. Okay. Right now we assume 0.95. Yeah.
Okay.
This is conditional discount factor. Okay, yeah, so what we're focusing on is these estimates of search costs separately from fatigue. Unfortunately, since we can't estimate prices, I can't put these in dollar terms, but what you should see is fatigue is much higher than the baseline search cost that we estimate. How much higher? I can put that, sorry, let me show you here. Fatigue is, if we look at the intercept for Zalando, right? Fatigue is something like 13 times, sorry, Zalando is about 13 times the fatigue effect and about 40 times the search cost effect. So basically, again, fatigue is much higher than the search cost here. If we look at the effect of, decreasing search costs or decreasing fatigue, decreasing search costs has kind of a modest effect here, as I was saying, because search costs are relatively small. Decreasing search costs increases searches by about 2%, transactions by about 1% across these categories. Decreasing fatigue has the largest effect on search gaps, obviously. So it speeds up the the spell, right? You get to the transaction much faster. And then in terms of searches and purchases, it also has relatively large effects on those, given that it has only indirect effect on both of them. So you see them kind of on par with the effect of decreasing search costs, even though again, fatigue has only an indirect effect there. The last thing I want to leave you with is looking at kind of the differential effect of fatigue on different websites. I ordered websites here by search frequency. So the 11 here is the biggest website. What you see is when we decrease fatigue, the bigger the website, the bigger the benefit from lowering fatigue. So we're going to think someone like Zalando is going to benefit a lot more from decreasing fatigue than a very small website. That's kind of the direction that we're going into. We're going to try to do a little bit more analysis here to see what the impact on different companies, but that's sort of what we have right now. I can stop here, right? What I've shown is this evidence that there are search gaps and that they're somehow related to fatigue, and then provided a model that connects the two. Thank you very much. I'm happy to stay here for a lot more if there are more questions, but I really appreciate the comments so far. Thanks.
Perfect. Yeah, we'll open it up.
That was on time too, a little bit on.
Yeah, and anyone can ask kind of as usual, any questions.
Can I ask something?
Yes.
I'm wondering basically how you differentiate between browsing and searching. So I understand that people exist who find it fun to look at stuff online, let's say clothes or whatever. So then I guess you could differentiate this by looking at people who also look at similar stuff that they just bought or something like this.
I think the way we can do, that's a very good point. Like you could also just, yeah, like browsing, another maybe explanation for search gaps.
Exactly. So then you should really see this, because if this brings me joy, then I may be exactly marginal utility decreasing. Maybe I want to exactly, you know, spread it out or whatever. But somehow I'm not sure you want to actually mix searching and browsing for fun in the interpretations.
Definitely. So we can look at you know, searches closer to a transaction, or look
exactly, or you could just exclude the guys who still look for shoes after they have bought something, or something like this, I guess.
Yeah. So that's I think how we're thinking about it as well. So looking, kind of connecting it with how likely you are to make a purchase, how close you are to a purchase, whether you just made a purchase. And excluding those people. Yeah, we haven't done that, but that's on our definitely on our to-do list. Yeah. If there's any other?
Yeah, could I?
Raluca? With the prices from the websites, have you tried using the Wayback Machine to, since you have the URLs that they were looking at and the time they were looking at it, have you tried going back and looking at the websites at the time that they would have been scraped?
Yeah, so the issue is, so I should have made it more clear. The fact that we picked the category of prices don't really change over time is both good and bad. We're gonna, if we use the Wayback Machine, we're probably gonna find very similar prices at a different. So that's I pose it kind of as a drawback of our data collection effort, but it's not really that. It's just in this category, prices change every 8 weeks, 10 weeks, or something like that. So
for your period of time, even if you had it, it probably didn't change much.
Yeah, I've used the Wayback Machine before, so that's definitely a great resource in general, but I think for the categories less, we're gonna benefit less from that, but yeah, thanks. I think there was another.
So I just wanted to go back to Dan's question. So it's hard for me to think of beta as like really time discounting, right? I mean, these guys are, it's I'm doing it today or tomorrow. It's not like I'm, you know, putting the money in the bank instead and getting my whatever. So how do you want me to think about it? And maybe Dan's idea of just like paying some fixed cost to wait because of my, you know, I don't know.
Yeah, I mean, if you never found the product that you really, really want and you want to buy it right there and then, I think that's kind of how we're thinking about it. Delaying, you're delaying the option to kind of own that product or continue search. So,
yeah, but then, you know, do I want to discount the search costs associated with that? You know, related to what Sandra was asking. You're
so that's the part that you were okay.
I don't know. I mean, I'm speculating, and I'm wondering whether kind of treating it as more a fixed cost rather than a factor would change the estimation. I mean, one answer is it does nothing. You know, my estimation comes out the same either way, so who cares? Like,
I think either way it would be hard to estimate that separately from the fatigue parameter. If it's a fixed delay cost or something like that, then it's very similar to, you know, in the data it's going to show up very similarly. So
but then how much are you relying on kind of functional form and
yeah, so or we would be able to identify kind of the difference between fatigue and that, and so not be able to, but we can think a little bit more. But your comment is more about like why we would want to discount the search costs. So discounting kind of the continuation value is more.
I mean, it's hard to interpret this as really kind of like time discounting in a sort of interest rate kind of way when we're talking about a day. You know, or if you wanted to do that, then you should whack it up to 0.999 or something. You know, I mean, like 0.95 isn't like the usual interest rate time value discount thing.
So that we're definitely gonna do, like try to show robustness or show the effects for different.
No, but the question's sort of about, you know, how to interpret it.
Yeah, no, definitely.
And I think mathematically you're tying your hands more than you need to, I suspect. Just purely because of, right, like if it's a linear, you know, disutility over time, like if it's just both of them are linear, you're just estimating the difference, which I think you kind of said.
Yeah.
And then that might actually make things a lot more tractable, right? Because then you're really tracking something a little bit more simple versus weighting is multiplicative, continuing is additive. This is not going to have as easy of a comparison, is just my loose guess mathematically.
I can see that. I think that's a good point, and we could try with, you know, we're trying now with this discount factor. We can definitely take that off and see if we can just get the difference between fatigue and a delay cost. So searching now, you know, increases your cost. Searching later increases your cost for a different reason because you have to delay. So there's like two different time costs.
And then you're weighing in the benefit of the decrease in the clock.
Yeah. Yeah, we didn't think about it that way.
So I am going to leave the room open for more questions, but I'm going to shut off recording and everything now. But everyone can stay and I'll leave.